Propagation of wave. In a wave, energy propagate in the form of signals and no material object is required to make the journey. For example, when we make a telephone call to a friend at a distant place, a sound wave carries the message from our vocal cords to the telephone. There, an electrical signal is generated which propagates along the copper wire. If the distance is too large, the electrical signal generated may be transformed into a light signal or electromagnetic waves and transmitted through optical cables. At the receiving end, the electrical or light signal or the electromagnetic waves are transformed back into sound waves traveling from the telephone to the ear. Now let us discuss two types of mechanical waves: transverse and longitudinal waves. If the constituents of the medium oscillate perpendicular to the direction of wave propagation, we call the wave a transverse wave. If they oscillate along the direction of wave propagation, we call the wave a longitudinal wave. First of all, we will discuss transverse waves. Let us consider a string with one end attached to the wall and other in hand. If we give a signal up and down jerk to the free end of the string, a signal pulse travels along the string. We assume that the string is very long as compared to the size of the pulse, so that the pulse dissipates out by the time it reaches the other end, and therefore its reflection from the other end may be ignored. If the motion of your hand is a sinusoidal function of time, at any given instant of time, the wave will have a sinusoidal shape. Now, let us monitor the motion of an element at a fixed point as it oscillates up and down while a wave passes through it. We would find that the displacement of every such oscillating string element is transverse, that is, perpendicular to the direction of travel of the wave. Such a wave is said to be a transverse wave. Now, we will discuss longitudinal wave. Let us consider the production of waves in a long air-filled pipe by the movement of a piston. If we suddenly move the piston to the right and then to the left, we are sending a pulse of pressure along the pipe. The motion of the piston to the right pushes the element of air next towards the right, changing the air pressure there. The increased pressure in this region then pushes on the elements of air somewhat further along the pipe. If we push and pull on the piston in a simple harmonic manner, a sinusoidal wave travels along the pipe. The motion of the elements of air is parallel to the direction of propagation of the wave. This motion is said to be longitudinal, and the wave produced is, therefore, called a longitudinal wave.